Good morning, everyone, to the UCOWR University Council on Water Resources webinar number 2 on emerging voices of tribal perspectives in water resources. We had a webinar on April 26th that focused on tribal waters and climate change. This webinar was recorded and is available online for viewing. Today, our webinar number 2 focuses on tribes and water quality and quantity. This webinar is part of a special issue that was released in April 2018, which focuses on emerging voices of tribal perspectives in water resources. There are several papers that are part of this journal, and we are featuring 4 of these papers in the series of the 2 webinars. So today we will feature a paper by Dr. Otakuye Conroy-Ben, which is on disparities in water quality in Indian country, and a paper by Crystal Tulley-Cordova on the Navajo Nation precipitation variability from 2002 to 2015. This special issue is focused on highlighting tribal voices in water resources and to highlight some of the great research that is going on across the United States in relation to water resources research and education with tribal nations. Here is a list of the 8 papers in this journal issue and is available online for free access downloading. We encourage everyone to visit the website and download, share with others, and we hope you enjoy these papers. We will go ahead and start the webinar at this time with the first speaker. The first speaker is Dr. Otakuye Conroy-Ben, who is an environmental engineer and faculty member at Arizona State University. She's originally from the Pine Ridge Indian Reservation. She received a bachelor's in chemistry from the University of Notre Dame and a PhD in environmental engineering from the University of Arizona. Her research includes water quality, wastewater pollution, endocrine disruption, and antibiotic resistance. She'll be presenting with her PhD student, who is Rain Richard. Rain Richard has a bachelor's in molecular and cellular biology from the University of Arizona and a bachelor's of science in engineering and chemical engineering and a master's of science in environmental resource management from the Arizona State University. She's worked in industry for several years prior to making her transition to research. Her current research focuses on the impact of chlorinated solvents on the PPAR endocrine disruption pathway. I want to welcome Dr. Otakuye Conroy-Ben and Rain Richard for the first part of this webinar number 2. Thank you.
Your speaker's actually Hey everyone, how are you? So my name is Rain Richard, and I will be presenting with Dr. Conroy on the disparities in water quality in Indian country. We are part of Arizona State University School of Sustainable Engineering and the Built Environment. So our outline for today will be the motivation and background, drinking water legislation, methodology, our findings, and then finally conclusions. Okay, so the background. There are 567 federally recognized tribes in the U.S., and each tribal nation has a sovereign status. Tribes may develop their own water quality standards, and this primacy allows tribes to establish and enforce their own standards. With that being said, though, they still need to meet the minimum EPA standards. Okay, so the objectives with the paper was to evaluate drinking water quality disparities in Indian country, and this was done by the use of EPA's Echo, and that stands for Enforcement Compliance History Online. You can see the link there and then a little snapshot of what it looks like when you actually go to the site. Okay, so some legislation. So the Safe Drinking Water Act was developed to protect human health, and it includes primary drinking water standards and secondary drinking water standards. Under the primary drinking water standards, you'll either see MCLs, which is the maximum contaminant limit, so that will either be by concentration or radiation units, and then you'll see treatment technology, and that's used when the detection method is just too time-consuming or complex. And then there are other provisions to protect water sources as well. Okay, so some examples of drinking water standards. You'll see that it shows the contaminants, how it's going to be measured or treated. So it'll be either an MCL or a treatment technology. And then also the health effects, as well as the source of contaminant, how it gets into our drinking water. So an example here would be cryptosporidium would use a treatment technology. Potential health effect would be gastrointestinal illness, and how it gets into the water, it would be either human or fecal animal waste. And there are some others like cadmium and benzene as well. Some other rules and regulations that work along with the Safe Drinking Water Act, and this is in chronological order. There's the surface water treatment rule. And so this came about in 1989, and this was for surface water or groundwater under the direct influence of surface water, and it needed to be filtered and disinfected. It set MCLs for pathogens, and it actually established treatment techniques for filtered and unfiltered water systems, again, to decrease the exposure of microbial pathogens. And then in 1998, there was the interim enhanced surface water treatment rule, and this was for systems that that served for 10,000 or more people. Again, it was for treatment techniques for cryptosporidium. You can see guidances when you go to EPA's website here, and you'll see requirements for covers on newly completed water reservoirs, mandated state-led sanitary inspections, and then it also started the data collection for risk assessment on disinfection byproducts. In 2002, there was the long-term 1 enhanced surface water treatment rule, and this played upon the surface water treatment rule, but now it was for smaller facilities, and these were to service less than 10,000 people, and again, it was microbial protection. And then in 2006, there was the groundwater rule, and this was protection of microbial pathogens, mainly fecal contamination in source groundwater as drinking water used by public systems. And there were 4 parts to this. There's routine inspection, monitoring, corrective action, and then the 4-log removal of viruses. And then finally, the long-term 2 enhanced surface water treatment rule came about in 2006. And when you go to the EPA's website, again, you'll see a lot of guidance documents. This was microbial protection measures, and this was for higher risk public water systems, mainly again for cryptosporidium, treatment techniques for uncovered reservoirs, and this started the stage 2 disinfection byproduct rule. And then moving on, I'm going to have Dr. Conroy explain the rest of the paper.
Okay, good morning to everyone. I will proceed with going about how we conducted our study and what the findings were. So on the screen, you see an introduction to EPA Echo, and this is a website made by Environmental Protection Agency, which allows consumers to access any water quality data within the past 3 years. And it is a by connection. So you can look at schools, you can look at communities, basically any, I guess, housing unit or building that serves greater than 25 individuals. So the EPA provides quarterly data, and it is updated routinely throughout the year. We access data from July 1st, 2014 through June 30th, 2017. And when you access this data, you can look by location, you can look by state, county, or city. You can look at drinking water sources, and then the data output would give you health-based violations, monitoring and reporting, and public notice violations, among others. Okay, so say you want to go and look at water quality data in your community. This screen will guide you on how to do that. In the upper left, you can do a search type. And what's nice about this site is that you can look at drinking water, but you can also look at hazardous waste, wastewater, as well as air pollution violations. In the geographic location, you can search by EPA region, by state, or by county. And then you can look further at Indian country. And that's what we did here. We looked at Indian country, and if you want to look specifically at your tribe, you can do that as well. Now, we're comparing the water quality, and the way we're doing that is to look at violations of water quality. So that is the next box down here where the arrow is pointing, history or enforcement and compliance. So you can look at communities that had no violations up to serious violations. And you can look at time periods and how many quarters that facility was in violation. In the upper right, if you wanted to look at specific systems, you can do that here. And here's where you can look at specific population size, source water type, if you're looking specifically at groundwater, surface water, source waters, that's available here. And finally, if you're concerned about a specific pollutant, you can do that down at the bottom. You just go to this little bar here, and you can pull up any of the 90 or so Safe Drinking Water Act pollutants, as well as other rule violations. You can also search for lead and copper violations. Okay, so say we went to do a search, and what I did here is I looked for any drinking water facility in Indian country. This is a type of output you would get. You would get a table with specific system names in the left, highlighted in blue, with the state it's located in, the system type, and I'll explain that in a second. Source water type is either groundwater or surface water, the population it's served, how many quarters this facility was ever in violation. Some facilities are not in violation, and some facilities are severe violators. Also listed are violation points accrued, which I will also explain in a second, as well as on the right-hand side, you'll see that with this search, there are 1,012 drinking water systems that report to EPA in Indian country. Okay, so this is a bit more information. This is pulled directly from the EPA website on the system types. You can have community water systems, non-community water systems, et cetera, et cetera. Also, the note is the source water type. Your drinking water can come from surface water or groundwater, or it can come from groundwater under the influence of surface water, or it can be purchased. Okay, and a little bit more of data interpretation. EPA keeps track of these facilities through compliance points. If there were any violations, the facility will be charged points, and this is the point system breakdown. A facility will be charged 10 points for acute MCL violations of coliform or nitrate, 5 points for MCL or treatment technique violations, nitrate monitoring and reporting violations, and then 1 point for public notice violations, for instance, if the facility didn't notify you of a violation. And there are more specifics listed here. So this compliance point total is cumulative for 5 years. And so the way we interpreted this data is to look at the annual point accumulation as opposed to the 5-year running violation. What else can you do? Well, you can go up in the data output to customize columns here, and you can actually pull out more data. And what pops up is this box here, and you can search by zip code. You can look at specific violations such as health-based You can look at compliance points and specifically contaminants. And I did that with one of these tribal communities listed here. Once you click on contaminants in violation, you'll get a little box telling you which contaminants have been exceeded. And then if you want to look at the specifics as a public consumer, you have that right. You can look at the detailed facility report for any drinking water facility, and that's shown here. You would basically need to click on the specific water utility and then just look down further at the report, and what you'll see is specific details of the violation. For instance, for this community, there were monitoring and reporting violations of the Stage 2 disinfection and disinfection byproducts rule, and also monitoring and reporting violations of total coliform rule. It'll tell you the time period and whether that was addressed or not. Okay, so what did we do? We looked at Safe Drinking Water Act violations in Indian country, and I'm using the term Indian country in quotes because that is the search term used by EPA, and compare that to non-tribal lands. We looked at violation points accrued, the drinking water source, and violations involving specifically public notice. So did the utility notify the public of any violations? Monitoring and reporting, are they routinely monitoring and getting the data out to us? And health-based violations. Rather than combining this data by EPA region, I aggregated it by state simply to be more, so that this report could be more accessible to the public. I know that not everyone may know which EPA region they are in. And ultimately, it does come down to state regulations, which tribes fall under. We are looking at points, and we're also looking at the population affected, rather than number of facilities, simply because facilities can serve 25 people, they can serve 10,000 people. So I felt it was more important to see the percentage of the population affected by these violations. And what did we find? Well, when we accessed this data in November, there were just over 1,000 tribal drinking water facilities that report to EPA. And most of them are considered small drinking water facilities, and that is defined as serving less than 10,000 customers. We had some other information available to us, but we did not analyze it. For instance, we did not look at urban water source similarities compared to non-tribal. So, for instance, if there's a tribe living near Metro Phoenix, which may have similar water qualities, we did not get into that level of detail. We also did not look at non-tribal MCL violations. To interpret this data, we have to go in and look at every single drinking water report. And that just wasn't feasible for non-tribal states. For example, in Michigan, there are over 10,000 drinking water facilities, and we just did not have the ability to go through 10,000 individual drinking water reports. Also, unavailable information, which may be important, depth water table. Okay, so what did we find? Well, we wanted to look at the drinking water source by service population. On the left-hand side, and the blue and yellow are the tribal water source, and on the right-hand side is non-tribal by state. And it basically varies by state. Now, I like to use Arizona as my reference point since that's where we're at. And most of the American Indian population in Arizona receives groundwater as their drinking water source. Okay, and in comparison to tribal communities in North Carolina, for example, where they get their drinking water from surface water. Okay, so what else did we find? If we look at point violation, we did find a statistically significant difference between tribal and non-tribal communities. If we normalize that per year, per 1,000 customers. There were more Safe Drinking Water Act violation points accrued in tribal communities than in non-tribal communities. And then if you look at the breakdown of health-based violations, which would be MCL or treatment technology violations, monitoring, reporting, and public notice, and we look at the percent of population affected, overall, more American Indians are affected by these violations, I would say a greater percentage, than non-tribal communities. And we looked further at this disparity ratio. So we looked at the violation points in tribal communities and compared that to violation points in non-tribal communities through a ratio, where violation points in Indian country were divided by violation points in non-tribal communities, normalized to their respective state populations. And if an R was calculated greater than 1, there was a disparity, so more violation points in tribal communities. If R was less than 1, more violation points in non-tribal communities, and this was organized by state. Okay, so for the state of Arizona, there was a disparity, more violation points in tribal communities than in non-tribal. And then again, compared to North Carolina, which does quite well in tribal communities, there are no violation points for the state of North Carolina serving Indian country. So their water quality is actually better than non-tribal communities. We also, what's unpublished in this data, but what we also looked at is if we look at the points and we address specifically MCL violations and monitoring and reporting. So if tribal communities address those specifically, this water quality disparity will be reduced. We broke these down by state. Health-based violations are in the top box, and you can look at your own state. Basically, if the green bar is higher than this black bar, you have health-based violations in water quality. In the middle plot, there are very little public notice violations across the board. So public drinking water facilities are doing a good job at notifying consumers. And then overall monitoring and reporting can be improved across the board. These are the percent of population affected by monitoring and reporting violations. I think what we're really interested in, though, is what are we being exposed to? So this is where we went specifically into each individual report to see if there were any violations with specific contaminants. And what I did was look at states where tribes or tribal community members were impacted by MCL violations, and that's shown here. Okay, so there are 9 states shown, and in the parentheses are the percentage of American Indian population affected by a drinking water violation during any quarter of this 3-year study. Okay, and then within each pie, you'll see the percentage of population, or what percentage of that population was affected by a specific rule. Okay, for example, in Arizona, looking at these blue shaded areas, Arizona American Indian population is affected by mostly coliform and revised coliform violations. Okay, a little bit by arsenic and a little bit by trihalomethane. We did not show data that affected less than 1% of the American Indian population. Of note here, the state of Wyoming, 40% of the American Indian population was affected by some type of drinking water violation during this 3-year period. Okay, and finally, we can lump all this data and see where are our contaminants coming from. So this is a contaminant by water source. And this basically breaks down groundwater and surface water sources and where they're contributing to in these health-based violations. And basically what you see are that most contaminants are associated with groundwater sources. Okay? For example, arsenic. Arsenic is a naturally occurring metal that is weathered from geochemical formations, as opposed to the yellow bars where you will see this is surface water contributions. And these are more associated with disinfection byproducts. So HAA, haloacetic acids, THM or trihalomethanes. You're going to see that when you have more natural organic matter associated with surface water. And you can read more about the details in our report. So in conclusion, I'd like to say that EPA Echo is a useful tool to inform communities of water quality. You can look at your specific water quality. We found a statistically significant difference in water quality violations in tribal communities compared to non-tribal communities. And this was more evident with monitoring reporting than health-based violations, which are the chemical contaminant exceedances. Again, this varied by state. So you really need to go in and look at your community and look at the surrounding area. And to correct this disparity, once again, we need to address monitoring and reporting. So ensuring that these facilities have adequate resources to even test and send out samples and to report on it. And then to address those exceedances. Okay, so how do we fix the arsenic problem or the coliform problem? That is really the only way to address these water quality violations. With that, I'd like to say Palamaya, that is thank you in the Lakota language. I'd also like to thank my student Rain for assisting with this report, and for Karletta and Jackie for organizing this special session. Thank you.
Thank you very much, Dr. Otakuye Conroy-Ben, as well as Ray Richard. This presentation was very interesting to see from a very bird's eye view what is going across Indian country related to water quality. So at this time, we'll have a 5-minute Q&A session. Please go ahead and submit your question in the chat box. While I'm waiting to receive questions, I have a question to ask. How did you consider pursuing this topic, and what is the literature like out there on this topic?
So I want to say this may be one of the first studies looking at nationwide water quality. I know there are publications on small facility water quality data, and in those studies the researchers do report higher water quality violations in smaller facilities, so results are comparable. But as far as looking at water quality data, that's not well known in Indian country.
Okay, great. It appears that I'm not getting any questions, so maybe Jackie is receiving those questions. While she's working through the technical difficulties there, I just want to welcome everybody again for joining this session. I had the honor of being the special editor for this issue, and this issue came about through my discussions with various UCAWR representative at a national conference several years ago in terms of trying to elevate the voice of tribal perspectives in water resources. And so I was invited to do a special session at the conference last year where Dr. Conroy-Ben and Dr. Ryan Emanuel presented on their work, and that resulted in submission of their papers, and as well as inviting others across the United States who are doing work in tribal water resources research. Okay, looks like we're not receiving any questions yet. So we'll go ahead and move on. I want to thank Dr. Conroy-Ben and Rain Richard for their presentation. And please visit the website and download their journal article and share with others. I found it very concerning that tribal water quality, tribal water facilities had 6 points higher on average than non-tribal facilities in terms of their violations. So I thank you for your contribution to the literature. I think it's very important to highlight that there's a lot of work that needs to be done in terms of drinking water for our communities out there in Indian country. So thank you.
Thank you, Karletta.
Okay. Well, there is one question that I just popped up. So I'll go ahead and ask it. Looks like we had some technical difficulties with the questions, but I don't want to let you go without answering these questions. But one individual said, what are the most important types of data that are lacking for Indian country?
I think that getting good water quality data, I guess, out to the community. I don't know that just regular tribal members know that this data exists. And so the data is there, it's just a matter of relaying it to the community.
Okay, great. And I also just want to note that Dr. Conroy-Ben is an assistant professor at Arizona State University, and she is from the Lakota Nation. And so she's one of very few Native professors in the U.S. Working on these important issues. So I want to honor her and her work and thank her again for being part of this webinar.
Thanks, Karletta.
Okay, great. Well, we will now move on to the next webinar. And I just want to let you know something unique about this issue is that majority of the authors are Native American researchers working on tribal water resources. And with such few of our Native students going into college, it's just a wonderful thing that this special issue has so many Native American hydrologists and water scientists working on tribal water research. So we need more students pursuing this work so we can help our people. So the next webinar is going to be by Crystal Tulley-Cordova, and she will be speaking on the paper that she wrote, which is on Navajo Nation USA Precipitation Variability from 2002 to 2015. And I had the pleasure of first meeting Crystal many years ago at an American Indian Science and Engineering Society conference, and just a pleasure to see how far she has come. She is currently a PhD candidate in the Department of Geology and Geophysics at the University of Arizona. She's a member of the Navajo Nation and grew up on the Navajo Nation, so she knows a lot about the water challenges facing Navajo Nation. She received a Master's of Water Resources with a concentration in hydroscience and a Bachelor's of Science in Earth and Planetary Sciences from the University of New Mexico. Her research interests include learning more about the interactions of precipitation, surface and groundwaters. Crystal has a passion for working with tribal communities. She realizes the importance of helping tribal nations dependent on water resources to understand the effects of hydroclimatic changes on their tribal homelands. So I welcome Crystal Tulley-Cordova.
Thank you, Karletta. So good morning. I'm Crystal Tulley-Cordova from the University of Utah in the Department of Geology and Geophysics. and I'll be sharing the research that I conducted with you, with the tribe. And this work wouldn't be possible without the Water Management Branch, Water Monitoring and Inventory Group, and specifically Irving Brady and Jerome Beekes, who have been collecting this data over 30 years across the Navajo Nation, and specifically also my co-authors, Courtney Strong from the Department of Atmospheric Sciences at the University of Utah, as well as Dr. Gable Bowen from the Geology Department at Utah. So it's important to note that the Navajo Nation is in the Four Corners region of the United States. It was established in 1868, and it is similar in size to West Virginia. It's the largest land-based tribe in the United States, and the primary water source is groundwater, and that was also shared in Dr. Conroy-Ben's presentation, where Arizona and New Mexico tribes largely rely upon groundwater in this region. And what the driving force for this work started at a very young age for me, and it's this phrase, "Two'e na'ate," meaning water is life. And it's a way of living and a way of our livelihood, really depending upon water. I mean, everything from the sheep that we have and raise to the medicinal plants that are used for cultural and traditional ceremonies, and the agriculture that we grow, as well as the wildlife and other vegetation throughout this region. And this is taught from a very young age, and it was instilled in me to be able to learn this philosophy, and has been the foundational work for what the research that I've been conducting thus far. And so growing up on the Navajo Nation, we have our own tribal newspaper, and before, I mean, it's a very rural area, so there wasn't computers and internet to learn about the outside world. And so we got a lot of information from newspaper clippings, and that's how I began learning more about the water issues across our nation and tribe particularly. And so I wanted to highlight these few titles. And in 2013, July 4th, 2013, was stated, Navajo Nation declares drought emergency. And then a few months later, in the same year, in the month of October, Navajo Division of Transportation fights flooding on Navajo Nation. And then as we progress through the years in 2014, as drought persists, Navajo Nation must secure its water future. And then in 2015, snow is pretty, won't redeem lousy water year. And what you can see with just even without looking at precipitation data, just looking at the news clippings, that there is some variability that is observed throughout this region across the Navajo Nation. So with that being said, it really has an impact on the different water resources that are located across the Navajo Nation. So as said, we do rely upon groundwater heavily, but we also rely upon perennial and ephemeral streams and lakes and springs for various reasons related to cultural and traditional practices, as well as overall livelihood of the Navajo people. And precipitation is what really plays a key role in being able to recharge these systems. And so why is it important to evaluate these changes in precipitation? And so as stated, I mean, it's a recharge source, but also as proven by Margaret Heiser Red Steer, that precipitation changes also impact the frequency of dust migration as well as the strength of winds. And we notice changes in precipitation in the ephemeral and perennial streams across the Navajo Nation. Particularly for this year, as I went into the mountains and examining the headwaters of perennial streams, we noticed that, I mean, the flow in these systems are really low, and that's because we had a low snow year this past year. And I mean, changes in precipitation also impact plant and animal populations as well as wildfires and the occurrences and the severity of them. And it could possibly also change different species composition, and it changes vegetative cover as well. And so before doing this work, like any good scientist does, you evaluate the previous studies that have been done before. And with that being said, this area, as mentioned before, is very rural. And so, I mean, in previous studies, individual location sites and data collection dates really vary throughout this region, and few sites have remained operational due to budget constraints. However, precipitation in this region had been evaluated in a technical review of a drought contingency plan for the Navajo Nation. And here's a graph of what the precipitation looks like, as well as the temperature patterns. And in knowing that this large area has various precipitation events, because I had grandparents that were in New Mexico and grandparents that were in Arizona, and just that 2-hour drive, I could notice the difference between the two in precipitation variation. I knew that looking at a graph like this, I mean, precipitation variability, it was something to keep in mind for the Navajo Nation. So with that being said, I also looked at online what data might be available out there. And there were co-op stations that were available bordering the Navajo Nation boundary areas. However, there were a few, and I wanted to talk with the tribe to be able to see if they had been evaluating precipitation trends over the years. And to my surprise, and I was happy to find out that since the 1950s, the Navajo Nation has been observing precipitation patterns in this region. And over the years, as you can see through this graph, the years are on the x-axis. On the y-axis, we have the number of precipitation gauges installed over the years. We can see that there, I mean, in 1993, that there was a large, as many as 30 were installed over the Navajo Nation. And the largest amount of precipitation collectors in operation at one time were 200 precipitation collectors. And so across this, here is a map of the hydrometeorological network for the Navajo Nation that they continuously monitor. And this, the specific group that monitors this is the Water Management Branch Water Monitoring and Inventory Group. And you can see that they have numerous tipping buckets, stream gauging sites that are evaluated to evaluate ephemeral and perennial streams on a monthly basis, as well as evaluating snowpacks. There are multiple snow course sites and precipitation sites as well. And precipitation sites, these are not on cellular network systems. These are manually collected precipitation data from a precipitation can that includes oil as well as biodegradable antifreeze during certain times of year, so to prevent freezing during the winter. But it's a evaluation of just putting a dipstick in and evaluating the month-to-month variation. And so these are done on a monthly basis, and this work evaluates 90 precipitation sites throughout the Navajo Nation, so in Arizona, New Mexico, and Utah, and that variability. Here is an example of what the areas look like, and I wanted to include areas where there is various types of vegetation, because when there are various types of vegetation, we can be able to make guesses that there is differentiation in the amount of precipitation amount throughout this region. And so you can see the tipping buckets that are there, the precipitation cans that are used, and what I won't be speaking about today, but also have been evaluating, are the stable isotopic precipitation and what it looks like in this region from 2014 to 2017. But in this study, I'll specifically be addressing the precipitation amount from water year 2002 to 2015 at 90 of these precipitation sites. And so when I asked the Navajo Nation group how they've been collecting this data, how they've been evaluating this data, a lot of collection has been done to be able to record the number in their database that they have in Fort Defiance, Arizona. However, in looking at these different precipitation reports, what I've noticed is that there wasn't an easy way to be able to evaluate the quantity of how much precipitation was falling within this region. So being able to look at a graph and see what is that month-to-month variability, what is that seasonal variability, and what is the year-to-year variability that we see over the years for this region. And to be able to evaluate that further, I wanted to be able to offer a tool to the water managers to be able to use. And in reading their reports, I mean, reading their water development reports as well as the drought contingency plans that the tribe has put out, I noticed that there wasn't any quantified amount. So it was referred that there was a bimodal precipitation regime, and that was noted, but however, a quantified amount describing the precipitation climatology throughout the year was lacking. And I wanted to be able to help with that after seeing all the data that they have been collecting throughout these years. So with that being said, I use Kmeans Clustering in R to be able to evaluate regions and create regions that are similar in precipitation amount. So rather than just imposing political boundaries or geographical boundaries on this data set, I wanted to be able to let the precipitation data speak for itself. And with that being said, what we see are 5 cluster groups that have similar patterns. So what was used in Kmeans Clustering was the latitude, the longitude, the elevation, as well as the precipitation amount. But it should be noted also that the data was normalized so that geographical features wouldn't be heavily biased for this regional data. And so we have 5 different regions. We have the northern regions in black, then in white we have the eastern area, in blue the southern area, and yellow representing the western area, and the higher elevation areas representing the Chusca Mountains as well as Navajo Mountain in green. And so just take a mental note of these colors because I'll be referring to them throughout. So throughout the rest of the graphs that I'll be presenting today. So in evaluating precipitation climatology for this region, it has been confirmed that yes, there is a bimodal precipitation regime across the Navajo Nation, and the variability is able to be seen with describing these groups. And what we notice immediately is that Group 4, which is representing the Chusca Mountains as well as Navajo Mountain, receives the majority of its precipitation from winter and specifically the month of February, whereas the rest of the Navajo Nation gets most of their precipitation from the North American monsoon during the summer months. And as we see that, we also notice, I mean, when we just compare Group 1 through 4, which is representing, 1 through 5, which is representing the rest of the Navajo Nation, excluding the high mountain areas, we see that the onset of the monsoon may vary, as well as during the peak monsoon time when that occurs is also a difference. So for example, on the eastern part of the Navajo Nation, which is represented by Group 5 and is gray in the graph, it sees the peak monsoon time in July, whereas the southern, the western, and the northern part of the Navajo Nation see peak precipitation amount during the summer during August. And one thing that is also noticeable in evaluating this precipitation climatology on a month-to-month basis is being able to see that June is the driest time of year. And if you remember back on July 4th of 2013 of that news clipping that I shared, it said that there was a drought that had occurred. But in knowing the precipitation climatology, we know that the monsoon rains start either around July 4th or a little after. So declaring a drought in June is not necessarily something to be able to be done, considering that we know it's a cycle that we're experiencing and that June is generally the driest time of year in this region. So also speaking to the seasonal precipitation throughout this region varies, and with the precipitation type. So winter precipitation are large frontal systems moving throughout this region coming from the Pacific, whereas the summer precipitation is really different. It's not over a large area. These are small localized storms being evaluated. And we can be able to see that when we see the precipitation from the winter and the summer monsoon. So one thing that's notable in winter precipitation, the least amount of winter precipitation in this region was in 2006. And for winter precipitation, a peak time for winter precipitation was the year previous. And this is also able to show, I mean, if we go and evaluate a different year and look at a summer year, I mean, in 2007, we can see that that was a peak precipitation year for summer precipitation. But one thing also to kind of speak to what I had said before, large frontal systems versus small localized systems, we can see large frontal systems have similar patterns throughout the years. And so this is large winter precipitation covering this large area. And as we progress into summer precipitation, it's a little different. There's more variability, and that's also speaking to the size of these storm systems where there's small localized storms that occur. And evaluating that year-to-year difference, here is a stark contrast at Denahoto, Arizona. And we can see that in 2014 that there was little precipitation amount and that is really seen in the vegetation that was able to grow. And so the sand, because of the lower amount of precipitation, the sand was very mobile. Whereas in 2015, if you'll remember, that was in an El Nino year, and there is more precipitation, therefore leading to the growth of more vegetation in this region. So also evaluating the year-to-year comparison, it's important to note, I mean, throughout the years 2002 to 2015, that there has been large variability throughout this time period. But one thing to note is that what are the contributions to total annual precipitation? Is it the same year to year? We know that it's not 50-50 year to year, 50 coming from summer, 50 coming from winter. But when we evaluate that summer to total annual ratio, we see that variability, and that's in the bottom graph here. So for example, let's take 2005, water year 2005. We see that that's a really big total annual precipitation year in comparison to the other years. And when we look at that, we see that the summer total annual precipitation ranges from around 30 to maybe around maybe around 0.45. And so that contribution coming from summer precipitation is that amount, whereas if we think about it, the opposite amount is winter precipitation. So this 2005 was really driven by a large winter precipitation. And when we look at another year, an example, let's look at this year, 2006. We see that the ratio is actually higher than around 0.55, and all the across the Navajo Nation, it's seeing that amount of precipitation. And so that amount of precipitation is largely due to summer precipitation when we really evaluate what that total annual precipitation is for the year. So most of it was due to summer. Winter wasn't really contributing that much precipitation. So when we evaluate precipitation throughout this region, it's important to be able to see, I mean, what is the within group similarity? Are these groups really different? Are they really similar? What groups what areas and regions throughout the Navajo Nation are more similar than others. And so just for an example, if we look at the annual panel here and evaluate group 2 and group 4, we see that they are at 0.58 correlation. So group 2, which is representing the northern part of the Navajo Nation, and group 4, which is representing the high mountain area, are similar by 0.58. And so that's not really a strong comparison. Whereas if we go to something like group 1 and group 2 being the northern area of the Navajo Nation, group 1 being the southern area of the Navajo Nation, we have a 0.85 correlation. And as we progress to look at winter and summer, we can be able to evaluate that further. And we see that group 1 and group 2 in the winter are well correlated with 0.95, whereas that correlation number goes down when we evaluate precipitation during the summer, where it goes down to 0.8. So that's how this graph is be able to tell us what are the similarities within the different regions that are described for the Navajo Nation when examining the precipitation amount. But more importantly, when you evaluate precipitation, it's important to know where your precipitation is coming from. And in the Navajo Nation, knowing where our precipitation is coming from, knowing those larger patterns will be able to help us know what our precipitation might look like in the future if we're observing these larger patterns. So with that being said, the winter, when examining winter precipitation and looking at P&A as representative of climate modes, different climate modes. So P&A is the Pacific North American, and then we have the Pacific Decadal Oscillation, and then Nino 3.4. And when we evaluate these different climate modes and teleconnection patterns, we can be able to see that on the Navajo Nation, we see the best correlation for winter with the Pacific North American pattern, therefore suggesting that our precipitation in the winter in this region comes predominantly from the Pacific Ocean. Whereas if we progress into summer, we see that that correlation with the larger climate modes really decreases. The climate mode that we see the most comparison with is with the PDO. However, I mean, it's still pretty weak in comparison to when we examine winter precipitation. So why is it important to be able to evaluate precipitation in this area and help the Navajo Nation be able to have a tool that actually has quantified amounts of looking at the precipitation climatology, examining the bimodal precipitation regime, as well as the annual variability in precipitation? It's important because it helps not only water managers, but other managers in this area, people that might be working in Department of Ag, maybe with livestock or with farming. The fish and wildlife people might be able to know what to expect. But then also on a political level, it really helps the Navajo Nation council delegates be able to know how to allocate money when it comes to extreme events such as flooding and drought. And based on this area, we can impose these different areas. Shiprock, Chinle, Tuba City, Crown Point, and Fort Defiance are representing different agencies, and money is allocated in those ways sometimes, but then also sometimes they're allocated on a chapter basis. So a chapter is similar to a township, the boundaries of a township. And so on the Navajo Nation, the sizes of these chapters really vary, but being able to have the precipitation quantified will be able to help not only water managers and other natural resource managers be able to plan for variation in water, but also to help political leaders within the Navajo Nation be able to understand the different variability, and with the different variability comes a different amount of money that they ask for emergency funding. So in conclusion, the Navajo Nation, climatology across the Navajo Nation really varies depending on the region. And the length of the onset of the monsoon is different for each region. And the monsoon precipitation contributions for total annual precipitation are for the majority of the Navajo Nation, whereas peak precipitation in winter is important for the high mountainous areas. And we are able to see those contributions differently for each region. And then when we evaluate the extremes in winter and summer, they're independent of each other. So when we have a bad winter, it doesn't necessarily mean we have a bad summer, and vice versa. And in evaluating the larger climatic patterns of teleconnection, we are able to see that winter precipitation is sensitive to the Pacific North American climate mode, whereas summer precipitation responds weakly to major climate modes, and that's also speaking to the size of it being small localized storms. And because we don't really know a lot about summer precipitation, the work that I've also been doing has been able to evaluate the North American monsoon precipitation, as I had mentioned, with evaluating the stable isotopes at 40 of the precipitation sites for the Navajo Nation, being able to see on a month-to-month basis what's that variability like. So I'd like to thank the Navajo Nation Water Management Branch, Water Monitoring and Inventory Group. They've been very helpful in the research that has been conducted in this area. Thank you.
Thank you very much, Crystal. The work that you did is wonderful. It's a great example of how you've worked closely with Tribal Water Resources Department to really be able to take a step further and do some analysis of a lot of data, and your work is just a huge contribution to the Navajo Nation, as well as I believe an example for all of us in terms of wanting to work with others. And just to conclude, I want everybody to visit the ucowr.org, where we have this webinar as well as webinar number 1 recorded for viewing. And we have the journal available online for free access downloading. This provides 8 papers stemming from comprehensive overview of water quality standards, water quality disparities in Indian country, as well as how lack of water can impact tribal economies. We also have a couple of papers by the Tribal College partners and information about tribal colleges and their work to adapt to climate change. Several case studies from the Lumbee tribe to the Navajo Nation, looking at water resources quantity, and then also perspectives on water resources in the Great Lakes region. So please view these, and UCowr is an organization that works to bridge universities and organization in water education and research. And there is a conference coming up in June in Pittsburgh, Pennsylvania. Again, my name is Karletta Chief. I'm an assistant professor, actually associate professor and extension specialist at the University of Arizona. And I'm honored to have served as the special editor for this issue on tribal water resources. I do plan to do another issue. This issue took about a year to bring together. So I plan on working with UCowr to do another issue in a couple of years. Thank you very much. Enjoy the rest of your day. Ahihet.